Good day, students. I hope everybody is doing well. Today, our main strand is geometry and measurements. Our substrand is measurements. Under the measurements, we are going to talk about how to calculate the size of a flat surface of a given shape. So calculate what the surface area of a given shape in centimeters and meters. Today's lesson has been taken from the new curriculum of Basics 5. Strands number 3, substrand 2, content standard 1, indicator 3. When you talk about area, the area is the size of a flat surface of a plane shape. The area of a plane shape or 2D shape is measured in centimeters square or meters square. So when you talk about the 2D shape, 2D shape means the two-dimensional shape, a shape with only length and breadth or width. Okay, good. Method for calculating the area of a plane shape or 2D shapes. One, we have the counting square method. We have the counting square method and the formula. When you talk about the counting square method, what does it mean? The counting square method is the use of a square to cover a particular surface of a plane shape. Each square represents 1 centimeter square or 1 meter square, which shows the number of squares that can cover a particular plane shape or 2D shape. After then, the total squares of a particular plane shape is the area. So with this, you make several squares to cover that flat surface of the given 2D shape. And then you count the number of squares that will be able to cover the surface. The figure ascertained is the area. How to make square of a plane shape? In case you want to use the counting square method. One, divide the length and the width by their given dimensions. So the length and its dimensions, so use the dimensions of the length to divide that line, and then you use the dimensions of width to divide the width according to its dimensions. After then, the square will generate on the surface of a plane shape. Then you count the number of squares that has been covered over there, and that is the area. The number of squares that covered a particular plane shape is the area. Good. Now, let's see the other method in case you want to use the formula. You can't just use the formula. You need to know certain things before you can calculate the area of a plane shape. Let's see the step that will be needed here. One, identify the units of the dimensions. You first check the unit or the measuring unit. Good. Make sure the SI units are the same. You make sure that the measuring units used for both the length and the width are the same. If not, then you convert all the units to one standard so that you can calculate the area for that particular shape. Then use what you know to get what you don't know. This expression means some shapes will be given dimensions, others will be not. So you use the dimension given for certain shapes to get those that have been omitted. Okay, so in case some shapes are having dimension, use the properties of that particular shapes, and then you generate the dimension for those that have been omitted from the question. That is why we use what you know to get what you don't know. So use the dimension given, and then with the properties of those shapes or the 2D shapes to also estimate the other side of the length or the width that will not be given to you. That is the meaning of the term. Use what you know to get what you don't know. The formula is area is equal to the length of the shape multiplied by the width of the shape or the breadth of the shape. So the length will be given a certain dimensions, and the width will also be given a certain dimension. Then you multiply those numbers, and don't forget the area is always measured in square. Let's quickly solve one or two examples under this topic. Example. Sorry. Calculate the area of the shape below. So you have a diagram which shows what this one is the 2D shape. It has the two-dimensional shape, only the length and the breadth here. So you're going to calculate the area for this one. Now with this, we said we have the two methods. We have the counting square method. Here, the squares have been already made here. So it's a matter of what? You count the number of squares that occupy this flat surface, and then that will be the size of the area. So each square here represents the 1 centimeter square. So when you add all the number of 1 centimeter square that have been placed here, that will be the total. So when you are using the counting square method, it means you count the number of squares that cover a particular plane shape. Okay, or you can also generate your own square by using their dimensions to divide the length and divide the width, and you will still get the same what squares that have been occupied here. Now let's count the number of square here when you are using the counting square method. So let's quickly write our solution. So let me write solution here. Good. So under counting square method, under the counting square method, let's count the number of square that occupies here. We have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 29, 30, 31, 32, 33, 34, 35, which means we have 35 centimeters squares here. Therefore, the area of this shape here is, therefore the area is equal to 35 centimeters square. Okay, I will make my square later on. Okay, good. Let me make my small tool here. So good. So that is the area of the shape given here, okay, which is 35 centimeters square. The square here are 35 when you are using the counting square method. Or if you want to use the formula, then you have to identify the length and the what? The width. So now let's see the formula. You want to use the formula. Area is equal to length of the shape times, let me come, times width. Okay, good. Now let's identify the length here. So with this, let's check the length. Let's check the longest part of the diagram here. So the length has been divided into 1, 2, 3, 4, 5, 6, 7. So 7 centimeters. And then the width has also been divided into 1, 2, 3, 4, 5, 5 centimeters. And then you multiply, therefore, you get the same answer here. So let's quickly proceed here. Then the area equal to the length. It has been divided into 7 centimeters, and then the width too has been divided into 5 times, so that is 5 centimeters here. And then when you multiply 7 times 5 is 35. That is 35 centimeters square. Before then, let me do my small square here. Good. Good. Now, when you use the formula, then you check the length, the longest part of this shape here. It has been divided into 7 parts here. So 1, 2, 3, 4, 5, 6, 7. And then the width here has been divided into 5 parts. So 1, 2, 3, 4, 5. And then we know the area is equal to the length of the shape multiplied by the width of the shape, and then the answer is 35. Good. So we have been using the both method here. The counting square, you count the number of squares that occupy the space, and then you write them in square. And here, using the formula, you check the number of times the length has been divided, and then the number of weight that the weight here has been also divided, and then you multiply the length by the weight, and you'll be able to get the same answer. Let's solve another example here. Now calculate the area of the shape below. So calculate the area of the shape below. The question did not be specific or did not specify with the particular formula that you're supposed to use, but it's advisable to use the formula to estimate or calculate the area here. Now, when you are using the formula, the first step that needed to know is what? You check what? The measuring units. You first check the measuring unit here. Here is the 20 millimeters, and here is the 7 centimeters. You cannot multiply the millimeters and the centimeters unless you convert to the same standard and then you do the multiplication. Okay, so here we have the 20 millimeters and here is the 7 centimeters. So let's write the solution first, and then you change to the millimeters to centimeters, and then you calculate. Okay, so just write the solution. Good. After then, let's change $20 millimeters to centimeters. Good. So to change 20 millimeters to centimeters, we know the standard. You must state the difference between the millimeters and centimeters before you can solve this one. So the difference is that for every 10 millimeters is equal to 1 centimeter. So let's solve this one in this way. Now, we know for every 10 millimeters is equal to 1 centimeter. Then because you want to change 20 millimeters to centimeters, you must always record the 20 millimeters or record the millimeters under the millimeters arena, and then you put any letter to represent its centimeters. So because the 10 millimeters, the down there will be recorded what? The 20 millimeters, because they are in the same arena here. So here the 20 millimeters is equal to, we don't know. So let me put K centimeters here. So the K is used to represent the unknown here. So the K centimeters. Okay, good. So we are going to solve. Let me use, because the K is also another unit that we use. So let me use Y. Okay, that is Y centimeters. Good. So once you have done recording, because the 10 millimeters is equal to 1 centimeters, and we are supposed to change the 20 millimeters, you must record the 20 millimeters under the 10 millimeters, because the arena here belongs to the millimeters, and here also belongs to what? The centimeters. The next step is what? You do your cross multiplication. So you do your cross multiplication where the coefficient of the 10 millimeters will be multiplied by the Y centimeters, and then the 20 will also be used to multiply the 1 centimeter here. Okay, in that order. Good. So let me write the next step. So the next step here is then the coefficient multiplying what? The y, which must be equal to the 20 multiplying the 1. Okay, the coefficient of 1 centimeter here. The next step, 10 times y is 10y. Okay, which is equal to the 20 times 1 is 20. Okay, good. So once you have done, because you want to find the y, not 10y, then you divide both sides by the number attached to the y. So you are going to divide both sides here by the number attached to the y. So you divide this side and then you divide this side by the number attached to the y. Okay, and what number is attached to the y? And that is the 10. Okay, so you are going to divide by 10. By 10. Okay, good. Now you do your cancellation. Then this 10 here will take care of this 10. Okay, and then the last 0 here will also take care of the last 0. The remaining number here is what? The 2 over 1. Okay, and 2 over 1 is the same as what? 2. Okay, good. So that is 2 centimeters. Therefore, y is equal to 2 centimeters. Good. Now you draw a new shape. Okay, good. You draw a new shape, and this time here is 2 centimeters, and here is 7 centimeters. Now they are all in the same unit, so you can calculate using the formula. Therefore, the area is equal to the length of the shape times the width and the length is 7 centimeters times the width is 2 centimeters. When you multiply them to, you get what? 7 times 2 is what? 14 centimeters square. So let me do my small square here. So 14 centimeters square. Good. Now we can also use the counting square method once you have gotten the same dimension. Then the counting square method, you have your diagram here. Now they say here is 2 centimeters, 2 centimeters. and here is 7 centimeters. Good. Now, under the counting square method, we said you should able to divide them equally so that you can get the same square size. But here, I'm not going to draw to scale, so you must accept any diagram that will come from this one. Okay, so the length here is supposed to be divided into 7 groups. So I'll use my thing to divide the length here. So once we have the 7, 1, 2, 3, 4, 5, 6. Okay. Now I have this one here. Okay. Good. Now let's count and check whether the length has been divided into 7. 1, 2, 3, 4, 5, 6, 7. We have our 7 here. Now the width is supposed to be divided into 2. So let me draw my width here. We're supposed to be divided into 2. Now, good. Now the weight here, so we have divided the weight into 2. So we have the 1 and 2, 1 and 2. The length is 1, 2, 3, 4, 5, 6, 7. So let's count the number of square here. We're supposed to be the same as the 14 centimeters square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So therefore, even when you use the counting square method, you should be able to get 14 centimeters square. Okay, let me make my square somewhere here. Now we have done. So always you check the dimensions, whether they are in the same measuring units, and then you move on. If not, you convert them into 1 unit and then you solve. Okay, good. Then let's solve another example here. Now calculate the area of the shape below. So the first thing you have to do is what? You check the dimensions first. Yeah, the distance from here to here is what? 3 centimeters. The distance from here to here is what? 6 centimeters. The distance from here to this side here is 7 centimeters. The distance from here to here is what? 2 centimeters. But the distance from here to this side is not given, which means we must use what we have here to get what you don't know or what you don't have. Then the distance from here to here too is not also given here. So it means we must also use what we have to get what we don't have here. Okay, before you can do the calculations. Now let me identify the joint wall here. The distance here to this side is only 3 centimeters. And then the distance from here to here is 6 centimeters. And from here to here is what? 7 centimeters. From here to here is what? 2 centimeters. Because the distance from here to this side is not given, and here too is not given, let's use broken lines to check whether we can use what we have here to estimate the other dimension that was not given to us. Now, using this one here, let me use the broken lines here. Now we know the distance from here to here is 3 centimeters. And then the distance from here to here is 2 centimeters. It's either you continue this line, to get this side, okay? Now we have gotten the two shapes. We are getting the two shapes here, which means from here to here, the distance from here to here must be 2 centimeters. 2 centimeters. Good. Must be 2 centimeters. Therefore, the distance from here to here must also be equal to this side, must also be 6 centimeters. Must also be 6 centimeters, which is 6 centimeters here. Okay, good. So when you put them together, the total distance from that end is 6 centimeters. That is 2 centimeters plus 6 centimeters. That will give you 8 centimeters. Good. That will give you 8 centimeters here. Now let's check this side too. Now you have gotten the distance. You have gotten the distance from here to here, because from here to here, when you cut this one off, you could see clearly that this one forms a new shape, which will be the opposite to this one. And when you cut this side off, this diagram here becomes what? Quadrilateral. And this type of quadrilateral here is what? Rectangle. And therefore the opposite of a rectangle is what? Equal. That is why, since here is 2, then the opposite from here to here must also be 2. Then when you come to the remaining shapes here, it's also quadrilateral, which has the 4 sides here. And this type of quadrilateral also means what? A rectangle. What the property says about that, the distance from here to here, when you trace it up, it must be equal to the distance from this point to this side, because the 6 centimeter ends here. It starts here and ends here, which is opposite to this line, and that is 6 centimeters. So when you put the total length from this point to this point, which is the 2 centimeters plus the 6 centimeters, and that will give you the total of 8 centimeters. So from here to here is what? 8 centimeters. Now let's check this side too. The same ideology. We know from here to here is what? 3 centimeters. So when you trade this side to this one, now let me write my broken lines here. Now let me break this line to this one. Okay. Now the distance from here to here, from here, this point to this point here must be 3 centimeters. What is 3 centimeters? Okay, good. Therefore, when you cut this one off, you could see that the shape that is quadrilateral here, which is also a rectangle, and the opposite must always be the same, where this side has been cut off. Okay, then you get the 4 shapes here. Okay, and the opposite here from here to this point must be equal to this side. Therefore, since here is 3 centimeters, here must also be 3 centimeters. And when this shape is also automatically off, the distance from here to here is 7. Therefore, the opposite of this side here must also be 7. Okay, because this one also form a rectangle, and therefore the opposite of a rectangle must also be 7. So here, from this point alone to this side here is also 7. Okay, so let me also write something down here. Now from here to this side too must also be 7. Okay, so here too is what? 7 centimeters. So when you total them, the 3 and the 7, when you total them here, the answer here will be what? The 10 centimeters. Good. Now we have used what we have here to get what we don't have. So now these are the dimensions that we are going to use here. So the total distance from here to this side is made out of 3 centimeters and 7 centimeters. So when you put them together, you get a 10 centimeters. The same thing applies to this side. The distance from here to here is what? 2 fold. We have the 2 centimeters and 6 centimeters. When you put them together, is what? 8 centimeters. Okay, good. Then with this, area that we are calculating is based on what? The 2D shape. A shape with a what? The 2-dimensional or a plane shapes here. So we are going to dismantle the shapes and get 2 shapes here so that we group them in what? In 2 rectangles. So let me first draw the first shapes here. What we can also get when you break this one down here. Now you group them into 2. Here, now we have this one. We have these shapes here. Okay. You can get this one from this diagram. Good. And then we can also get this one here. Good. Now, when you dismantle, you can get these two shapes from this diagram. And let's see the dimensions here. Now, already, we know the distance from this point to this point is the same as this point here. This point and this point are also the same. And then you have this, and that's okay. You have the four shapes here. So the dimension here is what? 6 centimeters. And the 6 centimeters. And then this side here is also 3 centimeters here. That's a 3 centimeters. And then we are getting our length and the width here. Now, when you come to this shape here, here is 2 centimeters. 2 centimeters. And then here is the total length. The total length from this side to this side is also 10 centimeters because it was made up of 3 centimeters and then 7 centimeters. When you put them together, you get what? 10 centimeters. That is 10 centimeters. Okay, good. Now with this, you can label this side shape A. Okay, and then here will be the shape B. Good. So we calculate the area for the shape A and then the area for shape B, and then we put them together to get a total area here. So let me start my calculation from here. Then under the shape A, the shape A, the area equal to the length times the width. Okay, and then the length of the shape A is what? The 10 centimeters, 10 centimeters times the 2 centimeters, 2 centimeters. And then the answer is 20 centimeters squared. Okay, so let me do my small square. Good. Now the shape B. It's too big now. Now the shape B, I want to change the color. Okay, so this one was shape what A. Okay, good. Now with the shape B, this the shape B, the area which is equal to the length times the width, and the length of it should be 6 centimeters, 6 centimeters times 3 centimeters. Then when you multiply the 6 by 3 is 18 centimeters square. So let me do my square here. So let me put this one here. Okay. Therefore, the total area for the shape is equal to the area helpful shape A plus area for shape B. Okay. So the area for shape A is 20 centimeters squared plus the shape B is 18 centimeters square, and then the total area for the shape is 48 centimeters square. Let me do my square wall. Okay. So yeah. Or somebody may also decided to cut the shape in other way around. So let's quickly solve that one too. They also decided to get a shape. Okay, let me come to get a shape in this form. Okay, and get the other shape. Okay, good. So you can also decide to dismount it in this form. And know the distance from here to here still remain the 3, and this time here is what? 8. Okay, the longest part, and here 2 is 2, and from here to here is 7. Now we know from here to here is also the longest part here. Okay, you can also decide to cut the shape in this form to get these two rectangular shapes here. Okay, and from here to here is what? 8 centimeters. So let me write the 8 centimeters here. Okay, so you have the 8 centimeters. So have the 8 centimeters here. Good. And then we still have the 3 centimeters at this side. The 3 centimeters here. Good. Then with this, we have the 7 centimeters because from here to this side here is 7 centimeters. So from here to here is 7 centimeters. Okay, good. Now we have 7 centimeters here. And here will still remain the 2 centimeter. The base of the shape here is 2 centimeters. Okay. Good. Now, let me label this one. This one will be the shape A. Let me use any other letter. Shape K. That is shape K. Okay. So that is shape K here. And this one will be shape P. Okay. So let me change this one color here. Make it shape P. Now with this, you're going to calculate the area for the shape A. So when you come here, the shape P, so here the shape P, which the area is the length times. So the length of the shape P here is 7, which is 7 times 2. And the answer here is what? 14. Okay, 14 centimeters. So that will be the shape what? Shape P. Let me put the shape P here. And that is 14 centimeters squared. Let me think my square here. So let me do my small square. Good. Then let me calculate the shape P. So the shape P is shape K. Okay, good. And then the shape K The length is 8 centimeters by the 3, and the 8 times 3 is 24. Is 24. Good. Now, let me do my square here. Now, to find the total area of the shape, you must add the area for shape P and the area for shape K. So, okay. So, let me write this one here. So, the area for shape K, and then the shape P. One is 14, the shape K is 24, and then P here is what? 14. Okay, good. Then 24 plus 14, that will be 38. Okay, same 38. Good. Let me do my small square here. Good. Now, with this one, irrespective of how you dismantle the shape or you cut the shape, you still get the same answer. You could see here that with the diagram 1 here, we have the shape A and B. The shape A and B, the shape that was cut from this side. So we're having this side, the distance from here to here, and that the 4 dimension is from this side to this side. Okay. And then this one too, from the top to this side here, that is the distance from here. Okay, that is how we cut the shape so that we can get the two rectangular shape or 2D shapes here in order to calculate the area for this one. Now, when you calculate the area for the shape A, we got a 20 centimeters square, and we said the area is always measured in square. And the shape B, we got the 18 centimeters square. So to find the total area of this one, in the same shape that we divided, so we must add them. So the total area for the shape A plus the shape what B. And when add the 20 centimeters square plus 18 centimeters square is what? 38 centimeters square. Or somebody may also decided to cut it from this end, okay? So that you get the bigger rectangle here and then the shortest rectangles here, okay? So you cut it from this side so that you get, that is why we got these shapes here, okay? The shape was this mountain from this side. Now we have this side, okay? Good. And we have already estimated the total length here. Remember the top length here was not given to us. And after our pair statistics, we were able to establish that from here to here is 8 centimeters. And then here too is what? 3 centimeters. We label this one to be shape K. And then the shortest rectangle here, that is what you see it here. Okay. So the distance from here to here is 7. That is why we got it from here to here is 7. And then when you multiply the shape P, the area is always the length of the shape times the width of the shape. That is why the shape P, we got the length with 7 times the 2, which is 14. And then the shape K, the length to 8, multiplied by the what? The width, which is what? The 3. So 8 times 3 is 24. And the total area for the shape is equal to the area for shape P plus the area for shape P. So when you add the two areas of the separate shapes, you get what? 38 centimeters square. Good. I hope you're okay. Thanks for watching. Okay. See you for the next lesson. Bye.